Hello guys, I hope everyone is fine. In today's video, we will be discussing the concept of merge sort. Now, there are three important things that we need to understand regarding the merge sort technique. Firstly, we need to understand the concept of divide and conquer strategy. So, one of the important constraints of merge sort is that it is following an algorithm design strategy, which is your divide and conquer. It means it will actually split the problem into two parts. It will try to solve the sub problems. It can also be divided into other sub parts till the splitting can be done. So it will continue to split. It will try to form the solutions of those sub parts. Then it will try to solve the solution of this and this, basically solving the solution of subparts, forming the solution and merging the solution for entire problem. So that's what divide and conquer strategy does. It divides the problem into subparts, solve those subparts and merge the solution to form the solution of entire problem. It means if it is dividing, it means it will basically split into two parts. It means the important point, the very first important point to notice is it will find middle index of elements. Then it will basically divide in such a way such that the first index to a middle, this is the first subpart of the problem, and the second subpart is middle plus 1 to the last index the problem actually works out, right? So what we will do is and after the splitting is done, the second important point that we need to understand is that whenever the solution is going to be formed from first to middle and middle plus 1 to last, when the solution is formed in such a way, it will try to store elements. It will try to store the elements in one array. It will try to store the elements in second array. Then when entire the things that we basically want to sort the elements, the entire merge operation is applied. That is merge operation which will be applied, which will provide the merge solution of comparing two arrays. Means two arrays will be compared. Which two arrays? First to middle and middle plus 1 to last. So these two arrays will be combined and they will form the solution of entire problem, and the solution is stored in another array, right? So, but again, the important takeaway, third important takeaway is we have to solve subparts one by one. Like we are going to take instance, we are going to solve it, we are going to basically find what we are required to do, and then we are going to solve it accordingly. So I've jotted down a particular scenario where L is representing the first index and H is representing the last index. So I'm taking four elements which are 9, 3, 7 and 5. Now, in this particular scenario, what first thing that we need to take care is that firstly we should know what is the very first part. The very first part is representing, the very first index is represented as L and the last index is represented as H. This is low, this is high, and this is the very first index. So its index is 1. We are starting with 1 and its index is 4. Now, the important point over here is that we are going to traverse from 9 to 5. So we are going to traverse here, 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 and here. But we need to understand that for traversing, this low element must be less than this particular element. It means the first index should be less than last index. And we have to actually split. Splitting is done by calculating the middle element. So middle element is calculated as 1 plus 4 divided by 2. That would be 5 divided by 2. And we are not taking 2.5. We are rather taking 2. It means my after splitting is done, my middle element would be 3. So it means if I will calculate the middle, which is calculated as 2, my first operation would be merge sort low, which is 1, and middle I have calculated 2. 2 means second index. So from low, which is first index, to middle, which is my second index. And my second merge sort operation is applied as middle plus 1. Middle plus 1 would be, we are going to calculate middle plus 1 would be 3, because second index is my middle. So middle plus 1 would be 3 till the last is my 4. So I have to calculate this also. Along with that, there is a merge operation that I will use for all the elements, but the first instance is 1, then the middle is 2, and the last element, last index is 4. Now we have to calculate the solutions of these particular things. How we have to go about it? Again, merge sort is a function which is calling itself again and again. And if we call this function again, what it does is, after first part is done, what we have done is we have splitted this problem into two parts. We have got 9, 3 and we have got 7, 5. Now, after this operation is done, I can take it as L. I can take this as H also, because that's what the call is. We have got the first element, which is 1, and we have got the 2 over here, and it is behaving, although it was a middle for this 9375, but L would be my first element and H would be my last element, and that last index is 2. So again, I will call this. Now the point is, the moment 9, 3 is done, I will split this problem even into 9 as well as 3. Now, when this is done, what we are going to do is, we are going to place 9 in one array, let it be L1, and we are going to put 3 in another array, let it be M1. Then we are going to compare these arrays, and whichever is less, that will be merged in entire solution. And if we basically solve 9 and 3, let's say if I are basically solving 9 and 3, whichever is less will come over here, and whichever is greater will come on the right side. So it means their solution is merged. So same applies over here with 7 and 5. 7 will be given to L1, let's say 5 will be given to M1, and then their solution would be 5 and 7, right? So 3, 9, 5, 7, and after we have to merge the entire solution altogether. The entire solution will also be merged in this way, in 3, 5, 7, and 9. This is a shortcut version of performing this. But if I go with the logic of this, firstly, I have got 9 and 5 to sort. Then I have got 7 and 5 to sort. Let's say first I have got 9 and 3 to sort. Then I have 7 and 5 to sort. Again, let me tell you that this will be converted with 9 and 3. They are stored in different arrays. This is stored in L1 and this is stored in M1. And their result, their combined result, which is a merged result, was stored in array A. And after comparing, whichever is less come on the left side and whichever is higher, which comes on right side. Same applies over here. Just check. Your N1 is a counter that works from a lower to middle value, and N2, which is a counter which is working from middle plus 1 to higher value. So it means even if we are going to merge the solutions of these whole parts, your 3 and 9 will be going with L1 and 5 and 7 will be going with L2, provided they are sorted. But since we are going to sort them accordingly, so even let me just explain this whole scenario where with how 9 and 3 are going to work out. Simply I is an index for L1. So if 9 is stored in L1, which is one array, L1 is one array, and N1 is a counter for this. 3, it will be another array, and N2 would be the counter for this. So they clearly have written N1, which is running from L to middle, and N2 is running from middle plus 1 to high. So if I have splitted the whole scenario, this becomes my L1 and this becomes my L2. I would basically, we have this index would be taken as I and this index would be taken as J. We are just comparing. If L1I is lesser than M1I, your combined result will be stored in A of K. This is the combined result, and the combined result would be stored in A of K. And whatever is combined result, guys, whatever is the combined result, we are going to, if L1 is lesser, then L1 value would be given to it. Else, your A of K, which will get the combined result, will get M1J, right? So 3 is compared with 9. Obviously, 3 is lesser. So your array would contain 3 first, and then it would contain 9. And your array works from lower to high. Now, this is what this whole scenario works out. Now, if let's say we have taken 9 and 3 and we have sorted this whole elements, and we have sorted it as 3 and 9, and the second array elements where we have taken separately 7 and 5, and then we have merged them to form another solution 5 and 7. Now, clearly, your A of K would contain how it would take all the values. This is my L and this would be my H. And again, this can be taken as my middle. Now, what I have to do is I have to, this array would be again L1. This array would be M1. This I would be the initializer for L1 and J would be an initializer for M1. And whichever value 3 and 5 are compared, whichever is less would be stored in A of K, and A of K is getting all the result of the solution. It is a merged solution. So 3 is compared with 5. Obviously 3 is lesser, so it will get L1 value. Then we will increment this and I will compare 9 with 5. So 9 is compared with 5, 5 is lesser. I will increment this J. 7 is compared with 9, so 7 would be there, and we are going to put one infinite value just for one sake that we may have some other comparisons to do. We have to compare this infinity with any other value. Let's say 7 is lesser than 9. We have put up 7, so 9 has to be compared with infinity also, right? So that is why we have written L1 n plus 1, which was a counter for one array as infinite, and M1 n2 plus 1 is infinite value. So 9 is now compared with infinity. Obviously 9 is lesser. We will put this array over here. This is the sorted version. This is known as merge sort. So merge sort, important takeaways from the merge sort are, the important takeaways are, firstly, problem is divided into two parts, then what we have to solve those two parts. How we will solve? Basically taking both the two parts in separate arrays L1 and M1. Then we have to compare the values and put up in another array, which is actually storing a result of comparison of two arrays. And whichever is lesser will be put up over here, second, third, and fourth. This is how you solve a merge sort problem. This is how the problem is solved. If you like this video, kindly like, share, and subscribe, and kindly share it with maximum audience so that we can reach numbers. So I have also put up this entire solving of merge sort problem in description box. You can download it. Thank you very much.